G'day and welcome back for another Space Engineers tutorial. Today we're going to be turning this ramshackle, terribly disorganized, ugly base into something a little bit better, or at least we're going to start doing that. And we're going to start doing it by building a hangar for our rover. There are a few things we're going to need for this hangar. We're going to need a large hangar door, we're going to need a connector that's centered so that we can easily park underneath it, and we'll need to hide a piston in the roof for that. We're going to want to have a relatively easy way to enter into the hangar, so we're going to want a neat transition from the voxels to the blocks. But the main bit that's going to occupy us today is building the hangar door. There are a few ways we can go about building hangar doors in Space Engineers. We've got piston mounted doors, we've got rotor mounted doors, and we've also got airtight hangar doors, which I have not unlocked yet. To unlock the airtight hangar door, you simply need to build one of the standard doors and then you'll be able to use them. We're going to take a look at a variety of different types of doors at the end of the video. This video is going to be focused on building a rotor mounted door. Because we're in an oxygen rich atmosphere that is mostly at a temperature that's not going to kill us, I'm quite happy to build a hangar that is not airtight. And I'd really like to go through a bit about how rotors and how blast door blocks work so that you can decide which way you'd like to build your hangar doors when you get to that point. And we'll talk through the advantages and disadvantages of each type at the end of the video. For now, what we need to do is start building the platform for our hangar. When you're thinking about the placement of a hangar, if it's going to be freestanding and you happen to have a slope around, it can be quite nice to transition from the slope of the terrain straight onto the hangar surface. So if we take advantage of this hole in the ground here and also take advantage of the hangar to fill in this hole in the ground, or at least cover it over, we can place our blocks carefully so that they just barely stick above the terrain there, which means as we place them out, we'll be able to get them to nicely meld into the terrain so that you've got a perfectly smooth entry. If you don't have that option, or if it doesn't really work for the design you're looking for, you can use the 2x1 slopes. The reason I try not to use them is that they aren't the smoothest entryway because they are still fairly steep. For certain vehicle designs, you may have troubles transitioning from the 2x1 slope to the flat surface again. This truck we've got here can do it quite easily, but I've had many designs in the past that haven't really worked so well with it. So I do try and use this sort of smooth transition wherever I can. We're going to need to work out how wide this hangar will be. And as mentioned before, we need the connector to be centered since it's centered on the truck. That means we will want it to be an odd number of blocks. And since the truck is just a little bit wider than 3 blocks, let's go with 5 wide for our entryway. So that's our 5 wide gap. We're going to need to make sure it's tall enough to fit our truck and the mining ship underneath or through the hangar entry. So let's check out by dropping a couple of blocks alongside here how tall this is. And it is just a bit taller than 2 blocks. So we will need a 4 block high entryway. The reason for that is the design I'm going to go for with our hangar door is one that flips up. So it'll be starting in this position, and then it'll rotate like this so that it opens up, allowing our truck to enter, and then it'll come down and close. And because it's going to occupy that 4th block, that's why we need this to be 4 blocks high. So when it's flipped up, you have 3 blocks underneath it. That little bit will make more sense once we get the door in place. I measured out the truck before, and to have a bit of room to move around it, we'll need this space inside to be 7 blocks. So there we go, that's about the size we need. Before we get on to building the door itself, let's have a closer look at rotors and at blast doors. On our left, we have our advanced rotors. This is the small grid version, and this is the large grid version. And on our right, we've got the standard rotor, large grid and small grid. On large grid, there's no great advantage to the standard rotor. The advanced rotor, however, does have an advantage in that it has conveyor access on both sides, so it can pass objects and components through it as part of your conveyor system. The standard rotor is slightly taller than the advanced rotor and requires ever so slightly fewer components in that its rotor part requires 4 fewer large steel tubes than the advanced rotor part. The mechanical end of the rotor is exactly the same between the two. Small grid though, there is quite a big difference between these two. You can see the size difference here. The advanced rotor is 3x3, whereas the standard rotor is just 1x1. So if you need to fit a rotor in a small place and you don't need components to go through it, you can use the standard rotor. For large grid, doesn't really make a difference which one you use. I have a tendency to go with the advanced rotor because I quite like the design of the rotor part. But that is purely aesthetics. There's no reason to choose this one for blast doors since you're not going to be having components run through it. But it's just something I do, and it's something I'm going to do here. If we take a closer look at these large grid rotors, you'll see that there is a mark on the rotor part, which I can indicate with the tip of my welder here. That's used to see the position of the rotor part relative to the rotor. At the moment it's sitting at 0 degrees, and on this one it's also sitting at 0 degrees. And then there are degree markings around this that move in a clockwise fashion if you are looking at the rotor from this direction. That is useful to keep in mind for when you're looking at allowing the rotor to move. If you wanted to move in this direction, you will want to move it in, you're moving it in the anti-clockwise direction, and therefore it will need to move in the negative. I needed a power source on here so that we could take a look at exactly how the rotor works. Our rotor has a bunch of options available to you, and what I've done here is add a little bit of armor on top so that we can so that we have a clearer idea of what's going on. One of the nice things about advanced rotors is that you can use the conveyor port as a way to access the control panel. I don't have any other means of accessing the control panel on here, and I didn't really want to build one since I could just use the advanced rotor for it. If we go down and ignore a lot of this stuff for the moment and look at the velocity markings. So if we set this to 1, this is going to turn in a clockwise direction at 1 revolution per minute. So this is moving that marker from 0 to 45 to 90 to 180, etc., all the way around, and it will keep going forever because if we look further down the advanced rotor, you'll see that we don't have a lower limit or an upper limit to our angle. If I set our upper limit to 180, it's going to stop when it reaches that angle. If I now click reverse, this is still going to move forever unless I set a lower limit. So I could set the lower limit to 101, and it's going to stop when it reaches that mark. There we go, stopped there. To change the direction of your velocities, you can either change the velocity on this slider or you can use reverse, and it's going to change between those two directions. It's going to apply the amount of torque you have specified here to try and move the rotor part and whatever is attached to it. If you're in gravity, you may need to adjust that to actually be able to move stuff. Our braking torque is the amount of force that's applied if the rotor is off in order to try and make the rotor stop. So to demonstrate that, what I'm going to do is I'm going to reset these so that they are unlimited, and we're going to set our velocity to 30 revolutions per minute. That is as fast as this can go. 30 in that direction or negative 30 that way. When I turn the rotor off, this is going to keep spinning for a while because of the inertia of the rotor part and the stuff that's attached to it. And we have 0 braking torque. If I start applying some braking torque, it's going to stop quite a lot more rapidly than it would without that applied. If I increase that to something actually reasonable, it's going to stop quite quickly. So if we have 1 kilonewton meter of torque applied for braking, when the rotor is off, it will come to a stop quite quickly. If we turn it on again, it's going to spin. And if we turn it off, it will come to a stop relatively quickly because of that braking torque. That braking torque is not applied when the rotor is on. When the rotor is on, you are using the torque to control the position of the rotor part. The next thing to look at with this rotor is really important when you're setting up hangar doors, and that is this rotor displacement down here. I moved my angle down because this displacement moves the rotor part up and down. Advanced rotors and rotors will have a different distance that you need to place them so that the blocks attached to them don't run into stuff that's to the side of the rotor, say something over here or here. You're going to need to adjust so that you can barely skim over the top of them. So if we want this to still turn, and let's turn it on so that it's spinning, And then we'll gradually adjust our rotor displacement down until it starts colliding with those blocks next to us. And we're going down. And you'll see that just beyond negative 10 centimeters, it runs into those blocks. So if we go minus 0.1, it's able to move. But if we go minus 0.11, it's going to stop. So for an advanced rotor, we want it at minus 0.1, and then it'll all still move. You may see sparks every now and then, but for the most part, it should continue to work without troubles. Now that we've looked at the rotor a bit more closely, let's take a look at blast door blocks, since that's what we're going to be attaching to our rotor that's going to be part of our door. Blast door blocks are very useful for moving contraptions. That's because they don't completely fill their block space. The standard blast door block will extend out to its four sides that I'm flipping up one at a time here, but doesn't extend to its full volume on the left or on the right. If we look at our blast door edge, this only extends out to its maximum limit on the side that's going down, forward, and backwards from our current orientation. And if I place one of these, and then use a little trick, pressing F11, if I place one of these and then save the game and change over to single player offline mode, we can then press F11 and get access to this debug draw menu. If we enable debug draw and enable physics primitives, and I have to double check that to make it work, we can then see the collision meshes of all of our blocks around here. These are the shapes that are used to estimate the physics interactions between the blocks. So for the base of our blast door block here, you can see it's a blue cubish shape, but the top here is marked out by an orange cylinder. And you can see there's actually a fair bit of clearance between the top of that cylinder and the top of the visual end of the block. That means we can make things look like they are completely closed because the visual part of the block can pass through objects, as the physics volume is smaller than it. An important thing to note about blast door blocks that I will just cover briefly is that the small block variants are not the same as the large block. If I drop this down, you'll see that yes, it's using a cylinder, but this cylinder is larger than the visual volume. It extends out to the full length of the tip or just barely below it. So you're going to run into problems if you assume this behavior when building stuff in small grid. You're going to need to give yourself bigger clearances when trying to make small grid blast doors. I'm going to place the rotor inside our entryway here, so starting it right here. I want to place it here so that the blast door, when we attach it, is able to occupy the full space of the opening. If I placed the rotor one block to our left, the rotor would be part of the opening, and I don't really like that look. We've now got our rotor in place, and we can see that the 0 degrees is facing forwards. So if we build our door going downwards with the rotor in its current position, it's going to need to spin towards the 90-degree mark to lift the door out to the front. Let's start placing our door down. So we're going to start with a blast door edge on top. Then as we get out to this end, I'm going to use the blast door corner. Something to note with the blast door corner is the position of that bracket. I'm going to place it this way so that all the brackets line up across the top, and then we'll have a couple of side blocks down here, and then another corner here, but I want that one to line up with the bottom, so we'll rotate it this way. You'll see when I weld these up why I did things that way. And then on this end, we don't need the sides, so we can just fill in the gaps that remain with our standard blast door block. So we've got this all down, and we're going to want to have a block in here, but I can't build it. That's because we've got to adjust our displacement. From before, we know that if we set the displacement to minus 10 centimeters, we should be able to pass things by directly next to our rotor. So let's set it to there and see if we can build our block down the end here. And yep, we can. But you saw the door start to shift. It's not really liking where those blocks are. It's going to be happier in a second though, because I'm going to weld up these 4 blocks on the end. Because the collision models between the build state and the completed state are slightly different, this will now work nicely. It will still be unhappy when I place blocks in here. In fact, let's check if that's right. Is it still unhappy? No, it's perfectly fine with me placing these here now. And that should mean we'll be able to open our door. So let's set this up. We know that we're currently at 0 and that we want to move towards 90 degrees because the marker is just down there. You can barely see it. And we want to move it to the 90 degree position. And we want it to stop there as well. So what we're going to do is we're going to set our lower limit to 0 degrees. That will change in a moment. And then our upper limit to 90. And you can see it's now changed to 0 because 360 degrees is the same as 0 when we're talking about a rotor. We've got our displacement set to -10. Our torque and braking torque are just fine. Let's set our velocity to 1. And it's going to turn. And it's going to lift itself until it reaches that 90 degrees and then it will stop there. And there we go. Nice open door. As a safety feature, I'm going to set our braking torque to the same as our torque. So I'm going to copy that. I'm going to control click on there. That's how I keep accessing these menus, is control left click on here. And by setting my braking torque to the same as my torque, I can ensure that if we lose power, that door isn't going to slam down. Because if I had that at 0 and we lost power, the door's going to come down, and if something's in the way, possibly the door and the thing in the way are going to get damaged. So let's turn it back on. It'll go back to its open position. Let's put our braking torque back up. So that door is pretty much set up how we want it, except it probably could do with moving a little bit faster. Yeah, 4 revolutions per minute should be good. Let's hop in our truck and see if we can fit underneath. I really hope this is the right connector to hit. Oh, yes, good. I did hit the right one this time. Here we go. We should fit neatly under this door. And relatively neatly through the gap. There we go. Perfect. I'm very happy with that. We fit inside. Ooh. But I haven't put this drill on the inside. If the door were to come down now, it'd slam over that drill. So we're going to need to extend our hangar out a bit, I think, to ensure that that's not where we feel like we should stop. Might give us an extra couple of blocks out this way. So that we don't have to keep going to the rotor to control the door, let's set up a button panel. And to use a new feature that's been added to the game, let's grab our button panel. Let's put it on our build planner. You can either left click drag it there, or you can middle mouse. And then when you go to your cargo container, you can simply press this button to withdraw everything that's needed for that block, or the collection of blocks that you've put in the build planner, so that we're far enough inside the door and this isn't going to create problems later. Let's pop it right there. Button panels are relatively easy to operate. You can access a control panel properly through this bit, and to set up the buttons to control an action, you can right click on it, you can click on it with F, you can left click on it, pretty much interact with it in any way while it doesn't have something assigned to it, and it will open up the menu so that you can set up the controls. What we want is a reverse action for our rotor. So that way if I click on that now with left click, it will close it. If you're wanting to reassign a button to something different, you'll need to right click on it or click on it with K. They're the default controls. If you left click or click on it with F, it will activate the button and do whatever is assigned to that button. Now, it's time to make this look a little bit more like a hangar while we get ready to set up our piston to have a connector on it. So there we go, we've got everything welded up, and I removed the blocks that were around the door since we're going to design something a bit nicer there soon. So to set up a connector for our truck, we do have the option of setting up something so that it's coming straight down like the piston over there, but that's going to end up relatively tall. What I'm going to do instead is have it off to one side. If we place, let's go with a block here, and then place a piston on top, we can now have some conveyor blocks coming across and coming down to a connector that's attached that way. I can't place that at the moment because our truck is in the way. Let's move it back out of the way. Place our last conveyor and our connector. and then we could lift that up to the correct height. We then have to ensure that the internal roof is high enough to allow that, but it should work relatively nicely. So we need this about another 2 meters taller. Let's set our maximum extension of our piston to 2 meters and reverse. And we'll keep adjusting that maximum extension until we get to a height where the truck can easily drive underneath. And still, it probably just needs to be a teensy bit higher than that. Yeah, let's go to let's try 2.1. Yeah, that's about perfect. So that's going to be a nice, neat connection for our truck. If we make some markings on the ground to make it easier for us to line ourselves up to that connector, we should be able to drive in and connect reasonably consistently. If we also have this as the rear wall of our hangar, we won't ever go far enough under this connector to damage our mining ship. Because if we had the connector further back, that would really be a possibility. I know I would almost certainly drive straight under the connector at some point and smash apart both the connector and the mining ship, because that's the kind of driver I am. And now for the aesthetic side of the build. The rough shape I'm aiming for is something that hints at that curved hangar style. That's sort of the military/temporary hangar build. And let's build up that to about there. In fact, I might build it up to there. Pop a 2x1 here, a 2x1 here, and then a half slope corner, and I went the wrong way to get that in there. And that's going to give a reasonable curve on the side there without extending way out past the building, which isn't what I want to do just yet, or don't really want to do for this build at all, I guess. And then we'll extend this across and we'll match that pattern on this side. There we go. That's a semi-curving shape. We could probably enhance it further, but for now, I'm not going to spend too much time on the armor design. I'm just going to come up with something that at least makes it look like I tried a bit and isn't just a ramshackle of the rest of the base. If we were to continue this design straight the whole way through, we'd probably end up with a very boring looking building, since the whole thing has exactly the same shape. We could do it though, that's up to you. You could try and make the building look a little more interesting by changing up the colors as you move down and having variable stripes or other things like that to make it look a bit more interesting. But what I tend to prefer to do to get something that looks a bit more interesting is vary the shape as well as the color, or at least vary the shape. With the first 2 rows placed, we don't actually need these blocks in here to be full for this door to look closed. They can be changed a little bit so that the next row can be seen a little bit through it. Bearing in mind, I do want to hide this rotor, so I probably want something close to, or potentially really do want, a full cube in here. And if we have a full cube in there, maybe we could put a 2x1 and then some half slabs in here, just for a bit of extra depth from viewing this from the front. So there we go. That's a bit of a more interesting armor shape that we've got going on here. I've used half slabs in the rear wall so that we've got some insets and it's not all one big flat shape. And on the sides, I've got an inner, smaller curve as well as the larger outer one. And with a little bit of detail and depth, it looks better. It's not good by any stretch, I would say, at this point. It could use a coat of color. If you wanted to create even more depth, you could introduce some windows into the top. And that would allow you to see through, adding an extra layer behind it, as well as changing up the thickness of the armor in various spots. But that's generally the idea you want to go with if you want an interesting design for your build. You want to try and introduce areas of varying depth and varying design throughout. And try and have some degree of pattern, I guess, with how you're doing it. As you can see, there's a fat section at the front and the rear, which makes some sense. The insets at the rear here make sense. And it looks okay. It's still going to get a little bit of love and a little bit more work, and I should have placed those inset slopes on the other side. I missed that aspect of it, but I'll get to that soon. But this works, so we're going to need a couple of buttons so we can control it and close it. And there we go. One hangar closed. Doesn't look too bad when it's closed. Not ideal that this is all square here, but with the shape and the movement of the door, there's not really an alternative. But I'm fairly happy with that. So let's take a look now at the other alternatives you could use for your own hangar door. And I've got them in another save, so let's load that one up. The first one we're going to look at is one with airtight hangar doors. Airtight hangar doors are a 3x1x1 block. This thing can extend out to fill the space that you can see indicated by that red outline. If I go here and click one of these buttons, these will open up and allow us to get through there without any problems. The nice thing about these airtight hangar doors is, as they say, they are airtight. You will be able to pressurize a volume on either side of these if they fully close off the entrance. The other really nice thing about them is that these are not subgrids. So they're not like pistons and rotors where it's technically an extra grid, which means that they will always behave nicely on a flying vehicle. If you've got a mothership and you want to have a hangar on it, these are your best option, because sometimes subgrids like those attached to rotors and pistons will not be accounted for in the mass calculations for your inertial dampeners on your ship, so you will drift slowly downwards while you've got them on, while you're within a natural gravity well, which can be a bit annoying and is one of the reasons that airtight hangar doors are great to use. A limitation of them is that this is as wide a gap as you can have in one direction with an airtight hangar door. Because it's a 3x1, you can only have a 4-block wide opening. So you can have a 100 block by 4 block or a 4 block by 100 block, but you can't have a 100 by 100 with these without using complex mechanisms that take advantage of merge blocks. And those are a bit more advanced that I would like to go into in this tutorial. The next design we've got is a piston-based door, which is going to move very similarly to those airtight hangar doors, except it's going to move a lot faster. These things are fairly slow to close. As you can see, they're moving... Yeah, I think it's... I'm going to guess it's about half a meter a second, maybe a little bit slower than that. But your piston can move up to 5 meters per second. So if I hit this, it's going to close nice and quickly. So if you want a door that can close quickly, that's one way you can do it. I am in creative mode, which is why I'm able to fly without any hydrogen. I enabled that through the Alt F10 menu here so that we could look at these designs a bit more easily. This design here is an alternative design for your rotor-based door. This one, the door is going to swing sideways when we hit the reverse button on our control panel here. There we go. This one's also set up very, very fast, so it opens very, very quickly. And then, like our door in our previous save, we've got the one that flips up. And then we've got over here a giant version of it. This is to demonstrate that idea that you need to be mindful of your torque if you're using something very big. And this is a very big door. Our rotor torque is set to 33.6 meganewton meters, and it cannot open this door fully. Gravity starts fighting it and starts to win when it gets beyond... How many degrees is that? Let's have a look. Rotor, about 55 degrees, 57 degrees. The gravitational force starts to win. We can increase this torque and get this thing to open up fully if we push it far enough. There we go. You could also be very clever and use pistons and multiple rotors to push and use the piston force to open up a door that's very, very large. And something else that I wanted to highlight here is that bracket on the corner pieces. This door is a perfect one to look at it with. If we aren't careful about how we place these down, we may end up with a door that looks like this. And you can see that that bracket's just not quite as nice as if we have it this way around, where the top and the bottom are equal and it's all nice. You could alternatively do it this way and it still looks okay, but it's just something to keep in mind when you're building with them that those brackets may affect the overall look of your build if you don't put them in the right orientation for your door. So there we have it. A completed little hangar. It probably does need a door somewhere that's human sized, but for now this will work well enough, I think. Oh, ready to lock. Let's lock. Parking brake probably doesn't need to be on, but I'll turn it on anyway. I'm now stuck with these wheels, so maybe that'll need to be adjusted. Ah, let me out. Let me out. There we go. Hop outside. Close the door. And it's all nice and neatly inside. Next time we'll continue working on this base. I haven't decided what I'm going to do yet, so it'll be a bit of a surprise. So there's that, whatever that is, and plenty more to come. And I will see you then.